All right, guys. Today we're going to go into intro to exponential functions. We're going to talk about money. You know, that's what everybody wants to make. When you guys get older, you want your money to take off exponentially, right? Can anybody describe exponential growth to me? Does anybody know what that even means? I see some hands like you kind of sort of know. What do you got? Yeah, multiplying on top of multiplying, not just adding on top of adding, okay? That's a great way to describe it, actually, okay? Basically, it's kind of like this. If you take something and you multiply it, at first it doesn't really seem to do a whole lot, but then like after a while, it takes off on you, okay? Hopefully everybody's got a calculator because you're absolutely going to need it today, okay? Everybody have a calculator? If you don't have yours, go grab it. But I'm going to show you about that. We're going to talk about money, and maybe after the notes are over, after the video's done, I'll show you guys exponential growth as far as money. If you guys are what, 14, 15 years old? Nobody in here is 16, correct? So you guys are young. If you start learning to save now, if you save the right way and save the right amount of money, your exponential growth will, believe it or not, by the time you're my age, you could probably be close to a millionaire just based on the money that you save, based off of interest compounding exponentially. Okay, so it does. People are like, when do I ever need to know this in real life? Well, when it comes to money, you absolutely want to know about exponential growth. Okay, all right. Do you guys have your paper? Did everybody grab a blank piece of paper? If you did not grab one, come grab one real quick. Okay, Cammy, you don't have one. Anybody else? Okay, here's what I want you to do. I want you to take your paper and I want you to fold this thing in half as many times as you possibly can. Okay. 7 or 8, or 7. Let's see how many we can get. And I'm going to pause it while you guys are doing this. Maybe. My camera just shut off. Yeah, we'll just leave it on. We're going to fold the piece of paper in half, and I want you to keep track of how many times you can do this. Now, let's talk about this while you're doing it. When you first started, how thick was the paper? Well, before you even fold, no. How many layers deep was it? One. Before you even fold it, with 0 folds, you had one piece of paper. Would you agree? You had one layer of paper. After you folded it one time, how thick was the paper?
3.
No, folded it one time. 2. You just folded it in half, okay? So what you did is you basically took your paper and you multiplied it times 2. Agreed? Which is now 2. Now, let's say I take the 2 pieces of paper, like the 2. Okay, think about it. It's 2 deep. I fold it. Now how deep is the paper? It's 4. I basically took that piece of paper, multiplied it, and then I multiplied it again. So now it's 4. You guys see a pattern here? So what would the next one be? Not 6, because you took, think about it. If it's 8 pieces deep, you fold it, now it's going to be, or if it's 4, it's now 8 deep. Yes? 1 times 2 times 2 times 2, which is now 8. Yes? So what would the next one be? What would the fourth? Now, hold on. What am I doing? The number of folds matches the number of 2's. Basically, right? What am I doing? I'm multiplying it times what? Multiplying it by 2, because every time I fold it, what happens to the paper?
It gets smaller.
It gets smaller, but what happens to the layers? It doubles. So we multiplied it times 2. Okay, so like 3 turns, or 3 folds, we have 3 2's. So we have 4. How many 2's am I going to have, guys?
16.
No, not 16 2's. 2 times 2 times 2 times 2, which is 16 layers deep. So let me ask you this. If in number of folds, it doesn't matter how many folds this is, okay? We'll talk about that in a minute, okay? There is an equation for this. There is absolutely an equation, okay? Now, how many pieces of paper deep did you get? 6 or 7? One person last hour or the other day was like, I got 8. I'm like, cool, let me see it. And it was kind of sort of bent, but he like couldn't, like it looked like it was just kind of rolled over. I wouldn't call it a fold. Okay. So usually people get about 7 deep. So let me ask you a question. If you were able to fold this paper 18 times, how thick do you think that paper would be? Now, it's not possible. But if you got to fold it 18 times, just brainstorm. Well, how deep do you think that would be? I'm going to write it. 18 folds. Well, how thick? Take a stab.
56.
856. Anybody else want to take a number? Huh?
2 million.
Oh, 2 million? Okay, 2 million. What'd you get? 24? 324? Anybody else want to take a number? Because here in a second, what do you got? 80,000? Okay. Okay. So here in a second, I'm going to show you how to figure this up. Okay. I'm going to show you how to figure this up in just a minute. Somebody's already got the calculator out there trying to figure it out. All right, so here we go. We're going to write an equation for what we just did, okay? We're going to write an equation for our paper. Now, I'm going to explain this equation to you in just a minute, okay? But your equation is this. Y equals 1. We multiplied it times 2 to the x power. Please write that down. 1 times 2 to the x power, okay? Now, does everybody have the calculator? This is where it's really, really going to come in handy. In your calculator, in the top left-hand corner, I want you to go to y equals. I want you to go to y equals. Okay? Make sure it's cleared out. If it's not cleared out, go ahead and clear it out. And I want you to type in this right here. 1, I'm going to type 1, and then I'm going to type a 2, and then I'm going to hit this button like always, and then I'm going to hit X, which X is the green button. It's next to the green button. There's a whole bunch of little symbols. 1, 2, and then I want you to hit that button and then hit X. Yes. Yes, I would do parentheses around both of them. Yes, sir. Hold on. It's the one next to the green one. Yep, that gives you the X. Now you got to hit the, you got to back up and do the caret first, and then do that. Okay. Now, go ahead and hit graph for me. And once you have it in, hit graph. What it should look like is this right here, right? After 0 folds, it was 1 deep. After 1 fold, it was 2. After 2, it was 4, yes? After 3, it was 8. If I would have went 4, it would have been 16, which is up there in the corner. Yes? So does your graph kind of look like this? Is that what it looks like? Okay. Exponential growth, right? Now, I want you to hit second, and I want you to hit graph again. You're going to have a table. Everybody with me? The question is on the 18th fold. So what I want you to do is on the X, I want you to scroll down to where it says X is 18. What'd you get?
252,000.
On the 18th fold, that paper would be 262,000 layers deep. Actually, I don't know. I don't think that would go to the moon. Are you confused? Now hit second and graph. Hit second and graph. There's your table. Okay? Is everybody with me so far? Yes, ma'am. This right here, you go to y equals. You have to go to y equals in the top left-hand corner. And type 1 with the parentheses, and then 2. Then hit this button above the division. And then hit the button next to the green button in your calculator. Should give you the X. Is everybody with me so far? So that's how you get back to the table, okay? To get to the table, when you guys use y equals in your calculator, you can actually hit second and graph, and it gives you the table of numbers that will actually work. It gives you the XY table. But for it to work, you have to put an X and you have to put a Y. For the calculator to work on that and to give you an actual table, you have to put an X and a Y in there. If you don't, it does not work. You have to put the X and the Y, which is why we did this. We put this equation. We have a Y and we also have an X. If you did not put the X, it would not work. Okay? It would just give you the same output every time. Okay? Which is okay sometimes. All right, here we go. What is the y-intercept and what does it mean? Oh, by the way, let me back up a little bit. Why was 0, 1? Does anybody know? Why was 0, 1 for the output? What did I tell you? The 0. What was 0 exponent always? 0 exponent is always 1. So that becomes a 1. So 2 to the 0 power is 1. And then what's 1 times 1? 1. So that's why 0 is 1. Okay? Basically, it just filled in that equation. Okay? All right, here we go. What is the y-intercept? The y-intercept is 0, 1. What does that mean? Your y-intercept is always your starting point. Okay? Please write that down. Your y-intercept is your starting point. If I'm saving money and I start with $500 in my bank account, my starting point on my y-intercept would be 0, 500. Yes? That would be my starting point. Okay? Is everybody sort of with me on this? Your y-intercept is your starting point. Okay? Now, what I'm about to ask you, you need to pay attention to this because this is important. What I'm about to is cannot happen, okay? This is not in real life, but there is a point to this. Continue the table backwards, okay? On your table. So in other words, let's say we get past 0. We're going the opposite direction. Now, you can't do this. I just told you to take your paper and fold it 1 time and then twice and then 3, all the way up to 7 times, yes? But what if we started with 0 and then we went backwards? Okay, which you can't do. But go ahead and go back to your table again. I want to show you something. Go to your table, and on the X numbers, instead of going up into the positive like a 1, 2, 3, 4, go backwards. Go down to Y and go to where the X's are negative. What do you tell me? What do you show about the decimals? What happens? You guys see that? What is it? What's it doing? In your table, you should be scrolling down into the negatives for your X. What are the Y values? They're all cutting in half, right? Scroll down until you actually get to where it's 0. Go ahead and stop. What happened? Did you find it? Why not? It's not possible. Okay? Please hear me on this. This is very, very important. If I told you to cut this piece of paper in half, let's say I told you to cut it, and you took your scissors and you cut the paper in half, and I said do it and do it and do it and do it until you can't see it anymore, does that mean it vanished? Can you cut something in half down to 0? No, you cannot. You cannot do that, okay? So, I mean, nothing can be cut down into 0. If you have anything and I keep cutting it in half, even if you get to the point where you can't see it anymore, there's still going to be something there, okay? Now, on your graph, it looks like it gets down to 0. Would you agree? It looks like it gets there, but it never fully touches, okay? We're about to get to that word in a minute, okay? So we're going to plot these additional points. So -1 would be 0.5, and then 0.25, and then 0.125. You guys notice that? And it did this all the way down, didn't it? It looked like it was getting very, very close, but it never fully touches 0. I see a lot of nodding. Do you guys understand that? Okay? And if we go back the other direction, it's multiplying by 2, multiplying by 2, multiplying by, and then it just starts boom, and then it takes off. Decimals, when you divide by 2, are still very, very small decimals. But when you multiply, eventually you're going to get to the point where you're multiplying and you have some massive, massive numbers. Okay? That's what we're talking about. Okay? All right, so here we go. I'm going to leave it up there. Exponential growth, this is important, has, and you need to circle this word, asymptotes. On number 6, right here, asymptotes. They are horizontal lines that your graph looks like it gets to, but it never actually fully touches. Okay? Asymptotes are imaginary lines that a graph gets really, really close to, but it does not touch. It gets close to 0. You get 0.000, whatever. You get some very, very close numbers to 0, but it never fully gets to 0. Yes? I just proved it to you. And I just hopefully logically just proved it to you. You can't cut paper into nothing. You can't do it. Okay, so it never fully gets there. So we're going to sketch our horizontal asymptote. Now, please hear me on this. It's going to be, all it is this right here. It's a vertical line that it almost gets to. And in this case right here, this is my line. It's y equals 0. That's called your asymptote. Go ahead and write that down. It's a little dashed line that it almost gets to, but it never fully touches. Sometimes it's at the top, sometimes it's at the bottom, but it's going to be a horizontal line. The horse is onto. The horse is onto. No? All right. Does everybody understand asymptotes? Okay, that's the line it almost gets to, but never fully gets there. Sometimes your graph might look like this, okay? And it might do that, okay? So my asymptote would actually be this one right here. Y is -2. Okay, you don't have to draw that. I'm just showing it to you. It's a line that it almost gets to, but it never fully touches. Good? All right, here we go. What is the domain? All right, here we go. Now we're going to talk about domain and range. I told you we would come back to domain and range, didn't I? You guys are rolling your eyes. Like, dude, I thought we were done. I told you we were coming back to it. What letter is domain? Perfect. You guys remember it. I like it. Love it. What is range? Y. Okay, good. So at least we remember that part, yes? We remember domain. We remember range. So here we go. On this graph right here, the domain. Now, keep in mind, both of these have arrows on the left-hand side. You just don't see them. Let's talk about domain only. I'm thinking left to right. Let's talk about left. Is there a point on the left side where you could tell me this stops? Yes or no? No. Why doesn't it? Because it has a what? It has an arrow. Okay, is there a point on the right as far as it'll go? Now, it goes up, but it's leaning that direction. It's still technically going to be going to the right also. Yes? So here we go. My domain is going to be negative infinite and what? Positive infinite. What letter is domain? X. Oh, I'm sorry. So I'm going to put an X in the middle, and I'm just going to do my little arrows. You guys remember that? Remember those? Domain and range. Now, let's talk about range. Let's talk about range. Okay, let me stop. Is everybody okay on domain? 99.9% of the time, your domain is going to be all real numbers, or it's negative infinite to positive infinite. Okay, that does not change. Okay, when we're talking about exponential growth, because your graph is going to be going this left to right, it's always going to be infinite. Okay, until we get to like algebra 2. Okay, everybody good? It's always going to be like negative infinite to positive infinite. It's just the way it's always going to be. You should not miss that. You should not miss that. Everybody with me? When we're talking about exponential growth, it's always going to be all real numbers, or it's going to be negative to positive infinite. Okay, the only way you might miss it is if you choose y instead of x. Okay, all right, here we go. Range, bottom to top. Yes. Is there a bottom? Is there a point where you can tell me, you know what? I think I know the bottom. What is it? What's the bottom number? -3. It's okay. -3. Is there a top? No. So infinite. What letter is range? Y. And then I just put my little arrows. Remember, the asymptote is going to be the bottom of your range or the top of your range, depending on how it's written. Everybody good? You good back there? All right, we'll make sure we're all right. What would my asymptote be? What's the horizontal line that it almost gets to? What? How do I write it? Y equals -3. It's a horizontal line. If there is no x, there is no slope. It's flat. Remember, y equals the number is flat. You guys remember that? We're doing y equals mx plus b. If there was no x, it's flat. Okay. All right, here we go. I'm going to pause this one. I want you to do this problem right here with your neighbor. We'll see if you can figure it out. Go. And we're back. All right. What did I tell you domain was? Negative infinite, positive infinite, x, and then less than. Yep. Everybody good? All right. What did we get for the range? Remember, range is what direction? Well, I see this, but where do I start? Always start at the bottom. You might want to write that down somewhere. Range is bottom to top. Okay. I think we've done that before. Range is bottom to top. Okay. Range is bottom to top. Okay. Always put the lowest number. Is there a bottom? Is there a bottom? No. Negative infinite. Negative infinite. Okay, because it goes down forever. It's down, which is negative. Is there a top? Yes. What is it? 2. What letter is range? Y. And then there. And it is less than 2 because it never fully gets to 2. Less than. Okay, but it's also greater than negative infinite. Okay. All right, what's the asymptote? Y equals +2. Here it is. I'm going to go ahead and draw it. Go ahead and draw it on your paper, guys. There it is. Y. What's my y-intercept? 0, 0. How many like, okay, I kind of have a pretty good understanding of this. Yes? All right, so here we go. I've showed you how to do this, yes? All right, what are we on? Flip that over. Let's see where we're at. All right, let's talk about aliens, okay? Now, I need to preface this. I'm not going to talk very long. The back page actually goes very, very quick, okay? This is not a true story. This is not a true story, okay? This was made up for this situation. I don't want to freak anybody out, okay? All right, here we go. You were on your way to make a camp, and you thought you saw another alien, okay? And then you looked again, and the dude shrunk, okay? And then every hour you measured to see what was happening. You recorded your data, and you found out he was shrinking by half every hour. Okay, so after the first time you saw him, if he's shrinking by half, listen, if he's shrinking by half, he went from 10 to what? Or 20 to what? 10. And then he went from 10 to what? 5. Okay, now, when you're cutting something in half, what are you technically doing? Dividing by what? Please hear me out. I knew you were going to say that. We do not say dividing when you're talking exponential. Okay? What fraction is the same as dividing by 2? 1/2. What fraction is the same as dividing by 3?
1/3.
1/3. What fraction is the same as dividing by 4? 1/4, and so on. Okay? 1/2, 1/3, 1/4, 1/5, 1/8, 1/9, whatever. Okay? But we never divide. You always multiply. Now, you can say, you know what, they're dividing by 2. But then you have to think in your mind, okay, dividing by 2 means that they are multiplying by 1/2. Does everybody understand that? Because that's why they did this right here. Yes? That's why they did this. Okay? So they do it twice, they get 5. So I want you, I'm going to pause it really quick. I want you to fill in the rest of this chart with your partner. Ready? Go. Okay, so if you guys put this in, you should be able to put this in your calculator and actually find your table, by the way. Okay, here we go. I'm going to squat down. What is it for the third one? I'm not going to fill this side in because this side's pretty easy, right? All right, here we go. 20 times 1/2 to the what? To the third. 20 times 1/2 to the what? 1/2 to the fourth. Okay, 20 times 1/2 to the what? 7th power. Now, if it says t, that would be 20 times 1/2 to the t power, because we don't know how. That's just a guesstimate. Like, you could put any number there, and it would give you a number. Does that make sense? Okay. All right, here we go. So it goes from 5. You should have gotten 2.5. Yes. 1.25. What is it after 7? It's not 0.625 because that would have been 5. What is it at 7, guys? 9 what? It's point what? Is that right? Yeah. 0.15625? Okay. It never fully cuts in half down to 0. Okay. It's not going to just magically disappear. It's going to be there. Anybody ever seen the movie Honey, I Shrunk the Kids? Okay. Where they use the machine and hit the guy with the laser and yeah. I mean, he shrunk, but he didn't shrink down to 0. Okay. He's still there. All right. Here we go. This is the only class I actually use that analogy with. You're welcome. I won't charge you extra for that one. All right, here we go. You guys ready for the equation? So what is the function rule? Y equals, here we go, y equals 20, 1/2 x. There it is. Is this exponential decay or is this exponential growth? What would you guess? Okay, it's decay. Okay, getting smaller. And I'm going to explain that more here in just a minute, okay? It's getting smaller. Stay focused for me. We're almost done. Stay focused, okay? I know it's the first day back. You had a long weekend. Okay, stay focused. What made it decay? Okay, I'm going to explain this to you in more detail here in a minute, but it's less than 1. Your growth factor is less than 1. And I'm going to show you that in just a minute. Just trust me on this. Your growth factor was less than 1. How tall will the alien be in 9 hours? We're not going to go into all that. Okay, let's just jump ahead. Everybody ready for this? Here's your equation. All right, let's talk about the official math part of this. Y equals ABX. Now, here's how you figure out the equation. This is what you're going to do today. It looks more complicated than it really is. Okay? Everybody hear me on this. It looks more complicated than it really truly is. Would you agree with this? I've said that more than once. Even people that have struggled with math, like last week when we were doing this on, what was it, Friday? We were doing this. People were like, oh, once they got the hang of it, they're like, this is actually really easy. You just got to find the pattern. Everybody with me? So here we go. Y equals ABX. So here we go. Your A represents your initial value. In other words, your what? Or your starting point, which is also known as your what? Starting point, which is also your y-intercept. So if you see 0 and then a number, whatever number that is on your table, that's your y-intercept. If you see 0 and a number, that's the number that goes in for A. Make sense? Okay, your B represents the growth, or it represents your decay. Okay, now please hear me on this. Your growth is going to be greater than 1. Growth is greater than 1. Anything above the number 1 represents growth. Anything less than 1 will be decay. Open your calculator just really quick. I want to show you something. What is, just pick me a random number. 5? Okay, 5. What is 5 times 1.01? 5 point what? 5.05. Did it go higher than the first number I gave you? Why? Because I multiplied it by what? A number greater than 1. Okay? If I go 5 times 0.99, tell me what you got. 4.95. Yes? It got smaller because I multiplied by a number less than 1. The reason we don't say less than or equal to 1 is because if I multiply something by 1, what do I get? I get the same number again. So the number has to be either above 1 or less than 1. If it's 1 again, you can multiply times 1 50,000 times. You're going to get that same number again over and over and over and over again. So it's got to be something different than 1 to either have exponential growth or exponential decay. Okay? Okay. We're going to talk about equations and all that stuff here in a little while, okay? All right. So the x represent, what is the x? Now, that's my exponent, so I'm going to put number of repeats, okay? I can't think of the word to put, like how many times does it repeat? Okay, we obviously know it's your exponent, okay, but that's how many times we're going to grow or decay or whatever, okay? Everybody with me? Online, if you got a different wording for that, you let me know. Put it in the comments below after you share it with your friends. All right, here we go. Exponential growth. Here we go. Here's your exponential growth. Yeet. Okay, just like that. Exponential growth. All right. Exponential decay is going to look like this. It's going to start high, and then it's going to finish down there. In other words, the number looks really good, and then all of a sudden, like you're losing money like crazy. Kind of like the fat alien. Okay, every time you looked at him, he was big, and then he just got smaller every time. Okay. All right, here we go. Practice. First of all, go to your graph really quick, or go to y equals. Please go to y equals. Now, you don't have to worry about 1/2. You can do this. Just because, type that in, please. I'm going to change it to a decimal just so you don't have to worry about putting a fraction in. Now, when you have like 0.3 or 1/3, don't change it to 0.3. Don't do that because it's not exact. Okay, you have to put a fraction. But something like 1/2, I could put 0.5 because it doesn't repeat. All right, everybody good? Go ahead and hit graph. Okay. Should look like this. First of all, what's my y-intercept? What's the first number? So my y-intercept, if I did this correctly, should be right there. Would you agree? Is that what it's on? Should be. Should be on 2. Is that where it is? Okay. Now, my asymptote should be y equals 0 because your graph should look like something like this. 1 goes to 1, 0, 0, so it looks like this. So this one's actually going to go that way. It's basically the same thing as before, just backwards. Is that what it looks like? Okay. What's my domain? What is it always? Negative infinite to what? Positive infinite with an x. What's my range? What's the lowest number? Talk to me, Jackson. Yep. What's my range? Bottom to top. What's the lowest one? Nope. Is that my lowest number? Is that my lowest point? What's my lowest point? 0. There we go. What's the top point, guys? Infinite. Okay. What's my range? What letters range? Y. Okay. You're going to get the hang of this a little bit, okay? Now, when we come back, eventually we're going to get to where we're working on, okay, what if you have 25% growth, okay? And you'll have to write the equation and do all that stuff, okay? Today is just basically identifying the equations, okay? Today's not going to be anything crazy. We're just going to do a worksheet, okay? Remember, what is growth? How do you define growth? What's the number? Greater than 1. What's exponential decay? Less than 1. What is my y-intercept? Nope. What is my y-intercept? The y-intercept is the what? Nope. Starting point. The y-intercept is the starting point, okay? So today what you're going to have is you're going to have a table where you're going to have stuff like this. And if you see like numbers and then you see like 0, 8, that's the number that goes first. So it's going to be y equals 8 and then whatever. Okay, that first, whatever 0 is going to be your first number. Easy, easy, easy. Okay, and I'll explain that more here in detail, okay? Good job. I'm going to give you guys a little bit of a break. Don't forget to click like, share it with your friends. All right, go. Yes.